Welcome to the lab. This explainer is presented by Forge College. Today, we're diving into security playbooks and next steps, the master architect's blueprint. We're taking those messy rough drafts you made in our last session, the synthesis and deployment strategy checklist, and turning them into a pristine, zombie-proof survival manual for your smart contract code. Remember, we're deep into the applied Solidity development track right now, specifically the Designing Smart Wallet Patterns module. So grab your technical pens because it's time to drop the ultimate architectural blueprint.
Okay, let's get right into it. We've got 5 main phases to hit today. 1. Moving from chaos to playbooks. 2. The anatomy of a defense. 3. Building your arsenal. 4. Automating the blueprint. And finally, number 5, next steps and integration.
All right, section 1, from chaos to playbooks, teaming the wild west of code. You know, in the wild west of Web3, you really can't just react to threats as they happen. We've got to stop taping our code together with fragile, ad hoc fixes. It's kind of like putting a tiny Band-Aid on a massive leaky pipe. Instead, we need to start integrating repeatable, safe patterns. When you're building a smart wallet, just patching a vulnerability here and there, yeah, that's a recipe for total disaster. We want a rock-solid, engineered foundation that won't suddenly collapse the second you add a new module to your wallet.
And that brings us to the concept of blast radius. Basically, this is the extent of damage a vulnerability can cause if it's exploited. Because if you place a mitigation in the wrong spot, the blast radius of a failure could literally take down your entire system. It's like accidentally leaving the main vault door wide open while you step out to make a sandwich. You might have the exact right fix, but if it's sitting in the core wallet instead of a low-privileged attached module, one tiny slip-up suddenly exposes all user funds. So we use playbooks to contain this blast radius. Okay, section 2, anatomy of a defense, the code pillars. A solid defense mechanism is built on 4 core pillars. First up, strict library imports. Think things like ReentrancyGuard, which basically stops attackers from double-dipping into your funds. Second, we have lockdown state modifiers, like only owner. That acts like a VIP bouncer for your contract. Third is precise withdrawal logic. And finally, operational controls. These are your ultimate break glass in case of emergency pause buttons. Together, these form the load-bearing walls of your smart wallet. Now, the absolute holy grail of our withdrawal functions is the checks effects interactions pattern. It's our primary shield. Think of it like going to a casino. First, you check the balance. Then, you update the ledger, those are the effects, and only then do you actually hand over the cash, which is the interaction. You never, ever do it the other way around, or an attacker is going to loop right back in and drain your wallet blind. So, we've got the defensive building blocks, right? The code snippets, the modifiers, the guards. But how do we actually standardize them so future integrators on your team don't accidentally reinvent a highly explosive wheel? Well, that brings us to section 3, building your arsenal, drafting the manual. To build an effective playbook entry, you just need to follow this 5-step workflow. First, spot the threat primitive. That's just a fancy way of saying find the basic loophole an attacker needs. Then, pick a primary code defense. Next, add a fallback control to catch any failures. After that, define your testing and monitoring signals. And finally, write clear integration notes so everyone knows who owns what. Honestly, this is your recipe for survival. The chief engineer's golden rule here is the rule of 3. Your playbook must always layer 3 things: a primary code control, exhaustive test cases, and operational fallbacks. If the code fails, the fallback catches it. If the fallback fails, the monitoring alerts you. Single points of failure? Yeah, absolutely unacceptable in our design. Our master artifact for all this is a playbook table that maps specific threats directly to their layered mitigations. Just to give you an idea of how this layered approach works, if the threat is an unauthorized withdrawal, your primary defense is strict access controls and signatures. But your fallback? That's nonce replay protection, basically ensuring a hacker can't just copy-paste an old transaction alongside off-chain KYC gating. This kind of mapping is your absolute source of truth. But here's the catch. A blueprint is completely useless if the builders ignore it and just start hammering away. So how do we force pull requests to actually abide by this playbook? How do we take human error completely out of the equation? Let's look at section 4, automating the blueprint, machine-readable safety. We can actually write a simple Node.js script that converts our playbook from complex JSON data into a clean, simple CSV file. Now, I know it might sound like boring admin work, but this simple spreadsheet format is the crucial bridge between your written rules and actual live code enforcement. The big takeaway here is that this automated CSV acts as a strict checkpoint.
It enforces CI system gates, forcing reviewers to verify that every single new code integration follows our established safety rules. It even generates pull request templates and ensures developers explicitly acknowledge mitigations before a merge is ever approved. It also keeps your living documentation updated. You literally cannot deploy your code unless you've checked the master blueprint.
And finally, Section 5, Next Steps and Integration, Preparing for Assembly. All right, we have our mitigations, our master playbook, and our automated checks. So your homework before our next explainer on integration is to actually assemble your playbook CSV artifact. I want you to select 3 high-priority playbook rows to apply directly to your wallet components, add explicit ownership notes so there's absolutely no confusion about who controls what, and prepare to map these components to your development teams. So, the big question is, will your integrated smart wallet survive the wild west of Web3, or will a single missing playbook row be your downfall? The choice is entirely up to how well you execute this blueprint. To get your hands on more of these design frameworks and really master smart wallet security, head over to forge.college. Thanks so much for joining me in the lab today, and I'll see you in the next explainer.